Assalamu alaikum class. I hope you are all well. In this video lecture, I'm going to discuss logical schema and the relation schema in the detail. So here is the overview of this video lecture. So I'm going to cover logical database design and relational data model. So question is that what is a relation? Okay, so I'm going to discuss relations. Next, I'm going to discuss different types of keys: primary key, composite key, foreign key, and recursive foreign key. I'm also going to discuss two types of integrity constraints. The first one is identity integrity, and the second is referential integrity. I'm also going to discuss about anomaly and the most importantly how to transform our conceptual schema to relational schema. So let's get started. So the question is that what is a relation? Basically, relation is a named two-dimensional table of data. Okay? So it consists of rows and columns. Rows are basically your records, while columns are your attributes or fields. Okay, so this is very important, right? Which I'm going to tell you now. That not all tables qualify as relations. Each and every relation each and every relation is represented as a table, but not all tables qualify as relations. So I'm going to discuss its reason shortly. But before that, let's clear what is a relation. Okay, so here are the few requirements of a relation. First, every relation has a unique name. Okay, and this one is very important. So every attribute value is atomic. Okay, what does atomic means? It means that it is neither multivalued nor composite. Whatever is inside the content of the attribute, right? It is atomic. It is neither multivalued nor composite. These two are not allowed in our relation. Okay, so every row is unique. It means that it has that primary key attribute associated with the help of which it is identifying that particular row. So every row is unique. Okay. Next, now these three are of, uh, in fact, these two are of a little minor importance, but these first four are very important. And the fourth one is attributes or columns in a table have unique names. Okay, so let me repeat the first four. Relation has a unique name. The attribute values are atomic. The row is unique, and the names of the column, okay, the names of the column are also unique. Okay, and the order of the column or the order of row is irrelevant. Okay, so order of the column and order of the row is irrelevant. Okay, so now let me discuss this point. Not all table qualifies relations because a table may have multi-valued in it. It may have composite value in it. It may not have something unique in it. Okay, so these two points may be absent in our table. So that's why not every table is converted or represented into a relation, but every relation, okay, every relation is transformed and is converted into a table. Okay, so these are the four major requirements, while these two are just to tell you that the order is of no importance as far as we are uh, talking about the relation. Okay, and the last point which is mentioned at the bottom, that all relations are in first normal form. So basically once we form our relational schema, we uh, uh, check for anomalies or check for redundancies or check for any issue. Okay, and then and when we fix those issues, and what is a technique which we use to fix that? It's basically normalization, and it's mentioning that all relations are in first normal form. So you just keep this is just a note, keep this point in your mind. When we will be discussing normalization, we will talk about it again. Okay, so here, this is the figure 2 which we were discussing discussing in the previous, like not all table qualify as a relation. So this is that particular figure, which is figure 4.2. So this is a table. Okay, we are looking at two different piece of information. The first one is our table, right? But this table is with repeating groups, while this is a table, but this is actually your employee to relation. Okay, now let me discuss what is happening in A. So we have few things common. First is that we have this. There are six attributes: employee ID, which is the primary key, name, department name, salary, course title, and date completed. So these are all the attributes of this table. Okay, so these attributes also belong to this relation as well. Okay, so this is employee ID, which is a primary key, name, department name, salary, course title, and date completed. So these two are common things. Acha. Next, what? How many records are there? So there are one, two, three, four, five. So there are five records in uh, table A, right? But now look at few things, okay? And pay attention. If you look at name, right? If you look at, let me use pointer now, okay? If you look at name, right? If you look at this attribute, okay, class. So here, this name, this is composite, right? Because this is our first name and this is our last name. Similarly with the rest, right? So the name is basically composite. Okay, so this is our composite attribute or composite data. Okay, so this is one thing which I want to highlight. Okay, next is our department name, which is like marketing, accounting, info systems, finance, marketing. Okay, so these are the name of the departments. We have salaries of the employees. Okay, so these are fine as well. Now look at the course. Now this is another very interesting attribute. Look at this course title. Okay, so what is happening in the course title and also date completed? So these two attributes over here, right? So this is a composite attribute, but what about these two? So if you look about this Margaret, right, which is whose employee ID is 100, sure. So Margaret has actually completed two courses. First is your SPSS and the second is surveys. So she completed these two courses, right? And the dates are mentioned over here. So, but but these two values, right? These two values belong to Margaret Simpson, right? And similarly, since there are two courses, to separate dates are mentioned as well. So in other words, if you see that this is a single cell, and in this single cell we have these two piece of informations. Okay, and similarly there are two dates here. So it means that this over here and this over here, this is actually multi-valued. Okay, and this is basically your composite multi-valued attribute. Okay, so this is composite. So in fact, this is simple multi-valued attribute. Okay, so let's say that this is simple multi-valued attribute. Okay, okay. Now, so the question is that, is this a relation? Is this how our relations look like? So answer is no. This is not our relation look like. Okay, so let me take you back. In the previous slide, I have explicitly mentioned that, right? That uh, in relation, let me highlight uh, using a highlighter on here. So attribute value is unique. Okay, so not multi-valued, not composite. Okay, so your attribute value is atomic in your relation. It is not multi-valued, not composite. Okay, fine. So this is the point which we mentioned here. But what about this point? Is it applying here? Answer is no, because we this table is not satisfying the atomicity. The attributes are not atomic. this attribute is composite while this one is multi-valued attribute. Okay, so in other words, this is a table with repeating groups, in fact. Okay, but let's transform it into a relation. So what we are going to do is that for each of these for each of these multiple values, we are going to replicate this data. Okay, so what we are going to do over here, we are going to put 100 Margaret Simpson marketing 48,000 surveys and the date. Okay, 7 for Chris as well, right? 110 Chris Infosystems 43K. Okay, like this. So it means that how many rows are there? 1, 2, 3, 4, 5, 6, 7, and 8. So there are like 8 rows. There should be 8 rows in our relation. So let's count: 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 rows. And if you look now, each and every attribute is um, okay. Each and every attribute is it's better, but there's still a problem, right? This is still, it has still an issue, right? And we must solve that as well. Okay, so the issue is that this name is still composite, but look at this course title. Now every cell has single value, like single value, single value, single, right? Just check, and no value, it's fine. No value is fine as well. Single value, single value. And similarly is the case with the date. So names are still composite over here as well. Okay, but we have solved the problem of multi-valued attribute over there. So there are no multi-valued attribute here, right? Um, but there are a few things which are debatable in this relation. Okay, so the first thing which is debatable is that the primary key is now compromised. Okay, so this is now compromised. This is one issue with this relation, right? And second issue is that the name is still composite, so we need to fix it. Okay, but let me take you back. So the point is that, so this was a point which we were actually discussing, that every relation, right? Every relation is a table, but not all table qualify as a relation. So I have discussed it in detail. So let's move ahead. So uh, so here is some more information about relation. So relation, or in tables, in other words, right, correspond with entity types and with many to many relationship types, right? So for every entity we have a relation, right? And the second point is that for every many to many relationship type, we are also going to have a relation. So this is what this first point is discussing. Okay, so remember, we have this conceptual schema in our hand, and there are two main things, right? One is our entity, and another one is our relationship. So for every entity we are going to have a relation, but for a many to many relationship we will also have a relation. Okay, so rows correspond with entity instances and with many to many relationships. Okay, column correspond with attributes. Okay, so basically row relations have rows and the columns. So rows are basically the data, right? While columns are basically the attributes. Okay, so one thing you must keep in your mind, and most of the student tend to forget this thing. There's a difference between relation and relationship. When we talk about when we are talking about relationship, it means that we are in the domain of the conceptual schema, right? We are talking about ERD, enhanced ERD, right? But when we are discussing this word relation, it means that we are in relational schema, right? We're talking about relations in the tables, right? So they are the difference between the two. Okay, so key fields. So keys are special fields. So they are special attributes, and they are there for a couple of reasons. So let's discuss those reasons. The first is that your primary keys are unique, right? So the primary key is basically your unique identifier. It identifies your records, right? For example, your registration number, CNIC number, um, employee numbers, okay, chassis number, etc. So these are all unique. So these are all primary keys. Now, this is this let me highlight this one as well, right? So I'm going to highlight this one. This is a point, the foreign keys, right? So this foreign key was not discussed when we were covering conceptual schema. Okay, so this was not discussed. So we are going to discuss the foreign keys in detail in our relational schema. So these are also the identifiers, right? Okay, and they enable a dependent relation, right, to refer to its parent relation. So basically, when we are talking about foreign keys, right? So the foreign key is our primary key attribute, right? So basically, foreign key is our primary key attribute, but this attribute is not in the parent table, but in some other table. Okay, okay, and we show this correspondence from the foreign key to the primary key, and this is exactly what this particular point is referring to, that your foreign keys are identifiers that enable a dependent relation, right, to refer to its parent relation. So it means that you are connecting your foreign key to your primary key. So the keys can be simple, right? This is the preferred way. We prefer that our key should be simple, right? So that our searching is optimized. But it can be a composite as well. Okay. So what is the meaning of the composite? So composite means that it's combination of uh, it's a combination, right? It's a combination of two fields or more, right? And this is the point which I was discussing when I mentioned the simple key, that keys usually are used as indexes, right, to speed up the response of user queries. So basically, with the help of these keys, we are accelerating the response of queries, right, the response of user queries. So if the key is simple, we will have the response in shorter time, and if the key is composite, then it takes little time more, so for our searching. Okay, so next I'm going to discuss the schema for four relations. Okay, so basically we discussed our conceptual schema in in lecture one, and we saw four different entities there, right? The first was our customer. Customer has a relationship with order, that is, customer places order. Then order has a relationship with order line, which is that order has order line, and then order line has a relationship with product. Okay, so product belong order line has products, one or many products. Okay, so there are like four entities over there and the relationship between them, and now we are showing, as I mentioned earlier, that for every entity you have a relation. This is what exactly is showing you over here. So we have this customer entity, we have this customer relation, we have orders, order line, product entities, and respective four relations. Now let's discuss. So this is how you are going to make or write your relations, where uh, you mention the entity name on the top, and then you make this table header kind of a thing, in which you mention attributes in each column. So the first one is your customer ID, which is a primary key, customer name, address, and then we have this address sub attribute, city, state, zip, and they are shown in asterisk. Okay, I will tell you the meaning of this asterisk shortly. Let's discuss order. So order ID, order date. Now this is interesting. This is your foreign key customer ID, right? Uh, its parent table is this one, where it's primary key. Then we have this order line, and if you look at the order line, this is even more interesting. So order line has two keys, right? Order ID, product ID. So, and its own attribute, which is quantity. So order ID is actually the foreign key in this order line table, because it is actually present in the order table. And similarly, this product ID, this is also your foreign key in order line, which is actually in the product table, and there it is, the uh, primary key. So what is happening over here? So basically, this order line entity has no primary key of its own. So what we do, we can uh, we can treat our foreign keys as the primary keys. And since one primary key attribute was not sufficient to identify our order line table, okay, so what we did, we made this composite uh, primary key out of those two foreign keys. Okay, now let me discuss this product relation. So the product relation has product ID, which is a primary key, and four more attributes: product description, product finish, standard price, and on hand. Okay, so let me show you some more things in it. So what we discuss here, this is the primary key, right? We saw it in ERD as well. This is the the thing which you should pay attention to when we are talking about relationship. But this is actually your foreign key. So ignore this note over here. And when I will be discussing the relationships, and when I will show you its transformation, then I will come back to this slide number 7, and then we will discuss this note as well. Okay, but at the moment, just keep in mind that this is our foreign key, and this is basically our composite primary key because it is the combination of two attributes. Okay, so this is this relational schema. Now, next, we are going to discuss constraints. So there were two constraints which I was discussing earlier. The first one, so basically, two main constraints were actually entity integrity and the referential integrity. But I'm also going to discuss domain constraints and action assertions. Okay, so domain constraint, it means that what are the allowable values of an attribute. Okay, so again, you are going to look at table number 4 on the coming slide. So we are going to see domain constraints shortly. But what is entity integrity? This is important, so please pay attention. It means that your primary key attribute should not be null, right? If it is null, then it's not a primary key. Okay, your primary key field must have data. It should not be empty, it should not be null. Okay, so if if this rule is satisfied, it means that your entity integrity is satisfied. Okay, action assertion is third type of constraint. And what are these things? Action assertions, remember when I was discussing in the previous lecture about student that is, if a student is to be awarded a degree, his GPA must be greater than or equal to 2, right? So this is actually your action assertion business rule, and we discussed a couple of further examples in the previous lecture, so you should go and check that out again, for if you are not if you don't remember it. So it's there in the recording as well, and the slides as well. Okay, moving on. So we were discussing this domain constraint, right? So it means that the allowable values for an attribute, and reference is just table 4.1. So let's check this out. Okay, so here is our list of attributes: customer ID, consumer name, address, city, state, etc. And right, this is the name of the domain, its description, and then the size. Okay, so let me discuss customer city. Okay, so customer city is an attribute, and its domain is all the cities, right? So in a customer city, you can mention set of all possible cities, and this is what it is mentioned over here, right? You cannot mention countries over here, and you cannot mention zip codes over here, right? Or you cannot mention states over here. Customer city must have a city only, right? And then you have set the size of this particular attribute, and it's 20. It means that your city, you can store all those cities in your table, which are like 20 or 20 or less characters. So if there is a city whose name is more than 20 characters, you can't store in it. So that is the domain, that is the size. Okay, so this is it means that the allowed values to be stored inside city is 20 characters, right? So you can specify a city that has 20 or less characters, right? But that should be your city as well. It should not be your state or postal code. But there are other attributes for this purpose as well. So these are the domain constraints. So I have discussed city, and similarly for the uh, rest of the topics as well. Now let me show you and discuss one more, and it's this order date, right? So it has set of all possible order dates. Okay, and then you are going to mention what kind of a format you want to store your order date. So this is the format which you want to follow, that you first have the month and the the day and the year, or you could have like this day, month, year, or some other format. But this is how you are representing your date, right? This is a domain constraint. Okay, so next I'm going to discuss about another constraint, which is integrity constraint. So what is uh, now this is differential integrity we are talking about, right? So we discussed three so far. We discussed domain constraint, we discussed entity integrity, we discussed action assertion, and now this is a fourth one. This is referential integrity. So referential integrity is basically uh, a rule which states that any foreign key value, right? And basically this was what we were doing when I was discussing uh, MySQL lab and lecture with you, that the foreign key value, right? The foreign key value must take a primary key value in the relation of one side. So let me read it again, okay? So rule that states that any foreign key value, right, must be a primary key value in the relation of the one side. It means that let's suppose here, let me discuss this scenario, right? Because this customer ID is your primary key, and here it is the foreign key. Okay, so let's suppose if I am mentioning here customer ID number one, right, as a foreign key. If I'm mentioning here customer ID number one, this customer ID number one should be there in like your this primary key must have this value of 1 in it. Okay, let me say that customer has possible values of let me write it, that your customer has possible values of 1, okay, 2 and 3. Okay, so now this foreign key over here, this is the foreign key over here, this foreign key can have these three values, right? This foreign key cannot have value of 4 or 0. This is not allowed, right? Right, it this customer ID foreign key here can take either 1 or 2 or 3, right? It cannot take any other value from these three values, right? For instance, 0 and 4, it cannot be 0, it cannot be 4. If if we say that there is this 4 in it, now this becomes correct, right? But this is still not correct. Okay, this is still not correct. So this is what is being discussed over here, that that any foreign key value, right, must exist in a primary key, right? If this is true, if this is true, then this means that our referential integrity is satisfied. Okay, and what is the benefit of applying or enforcing referential integrity on our in our database? So for example, uh, there are we can implement these delete rules, right? So and there are three set of possibilities which are being discussed over here, right? uh, and this is that if this referential integrity is there, right, if this constraint is applied in our tables, on our tables, right? So so we can apply these different types of delete rules. First is that this is the first one, what we can do, right? First is restrict, second is cascade, and the third is our set to null. Okay, so by restrict we mean that we are not allowing delete, right? We are not allowing delete on the primary key side, right? So don't allow delete of parent side of related row, right? We can delete the foreign key, but we cannot delete the primary key attribute. For example, you have, as I was discussing earlier, that over here we have customers with IDs 1, 2, 3, 4, and these customers gave some orders right here. So if we delete customer ID or record from here, it's fine, it is allowed. But if we are going to, like, the customer exists in the order table, and we delete customer ID number one here, it's not going to be allowed if we have implemented a referential integrity rule, right? Because try to understand this order table has these orders coming from these customers, right? So there can be one or many orders in it from the same customer, and if we delete that customer from here, so what is going to happen, right? So this particular value is not present here, so the reference is broken, right? There is no reference. It means that our referential integrity constraint has been violated. So this is not, this is controlled from, this is controlled over here. So we, if the referential integrity constraint is applied, we can practice delete rules, and there can be three ways we can apply delete rule. The first one is that restrict, we don't allow the deletion of the parent. Okay, the second is cascade. Okay, so this is a thing. Okay, fine, if you are deleting from the parent side, it means that all the records from the child also deletes. Okay, it's like two ways. So whatever is happening with one side, it happens with the another side. So automatically delete dependent side rows that correspond with parent side rows, right? So both records from both sides are deleted. If let's suppose our uh, customer number one has placed four orders, okay, and we deleted this customer ID one, it means that in the order table we also deleted those four records. This is how your cascade rule works, right? The third one is set to null. It means that don't lose the data, right? You keep the data as much as possible, right? The first one is like restricted. Okay, no, don't, you are, the delete is not allowed, right? The second one is saying, okay, remove the data from both ends, right? The third one is saying that set to null. Okay, it says that, okay, fine, delete the data from the parent, but set the foreign key in the dependent to null. Okay, because we have to keep our reference, right? We want it not first we don't want it to be broken, but if it is broken, at least the value should be null. So it means that there's no reference in the parent table, right? So there are data which is in our foreign key table, but there is no reference of it in the parent, because the foreign key is null, and null foreign key means no data of that particular record exists in the parent table. Okay, so there are these three possibilities which we can apply on the delete rules. But when this is possible, when we have configured differential integrity on our database, right, between our tables. So this is the practical demonstration of this is where you're practically looking at the differential integrity. So these are those four relations which we saw earlier, and now you see that, look at this thing, the arrow. This arrow which emanates from your foreign key, and its arrowhead is connected with your primary key. This is basically your referential integrity constraint. Okay. Similarly, this is the foreign key over here. This connect with the parent over here. This is the foreign key, it's connected with parent over here. So there are three integrity, referential integrity constraints applied in these four relations. Okay. So the first is between the order and customer. Second is between order line and order, and the third is between order line and product. Okay, so we can label our referential integrity on our relational schema, right? We apply it in the database, and we also show it on our relational schema as well. Okay, class. So next, this is a very important topic which I am going to discuss here. And in this topic, we are going to transform our conceptual schema, right, into our relational schema. So we have to map different aspects of our conceptual schema into the relational schema, and all those aspects, all those constructs are discussed. Okay, so first we are going to talk about the regular entities, right? So we are going to map regular entities to relations. Okay, now in a regular entity we can have these three types of attributes: simple attribute, composite attribute, and multi-value attribute, right? So what happens with our simple attribute, what happens with our composite attribute, what happens with our multi-value attribute, we are going to discuss it shortly. Okay, so so let me read what is written over here. So simple attribute. So simple attribute are mapped directly, okay, directly onto relation. Composite attribute. In composite attribute, only simple components are mapped, right? So we have this attribute, and it has its component. So we are going to make the components part of the relation, right? In the multi-valued attribute, now this is very interesting, right? Multi-valued attribute, we are going to create a separate relation for it. Okay, so for a multi-valued attribute, we are going to create a separate relation, right, with a foreign key, right, taken from the superior entity. So how these three are being mapped, so let's discuss an example. Okay, class. So this here you are looking at on the top. This is your conceptual schema, and this is your ERD, and at the bottom you have this conceptual schema and your relation. Okay. So we have this customer entity over here with three attributes: customer ID, which is a simple attribute; customer name, which is the composite attribute; and customer address, which is the composite attribute. Here we are mapping a regular entity. So what we are going to do, we are going to write this customer, right, name on the top, and then we are going to make this table header. And here we are presently looking at three attributes, one, two, three. So we'll make three columns. The first column is for customer ID, second is for customer name, third is for customer address. Okay, so look at this customer ID. This is a simple attribute. Simple attribute is mapped directly. Okay, but if you think about customer name and address, both are composite. So how composite attributes are mapped? Let me show you. So for example, we say that over here you are looking at ERD where this customer address is shown with its component, right? The customer address is broken down into street, city, state, and zip. So when we are going to label this composite multi-valued attribute, what we are going to do, we are going to mention street, city, state, zip only, and not customer address. Okay, so we are not going to mention the customer address. Okay, so we are not going to mention the customer address. We are just going to mention the street, city, state, and zip. And you are looking at all those attributes in the relation. Street, this is the first city, state, and zip. Okay, so all these four attributes are mapped over here. If your customer name is also composite, that is first name last name, then you are going to map that as well over here. So first name last name. Okay, fine. So this is how you are going to map your composite attribute. Next is our multi-valued attribute. So here you are looking at the employee entity with three attributes: employee ID, employee name, employee address. So we have discussed all these three. Let's focus on this skill multi-valued attribute. So when we're discussing the description, it was mentioned that for the multi-valued attribute, we are going to make a separate relation. So for skill, we are going to make a separate relation by the name of employee skill, and it has two attributes in it, right? This is your foreign key. So skill, employee skill has this foreign key, which is actually the primary key in the employee table, because we want these two, that is employee and skill relations, to be connected. Okay, so we don't want the relation to be broken down, right? So that's why we have made this employee ID as a foreign key in the employee skill. And then we have skill attribute over here, right? And the combination is your primary key, because a single employee can have multiple skills, so that particular employee ID is going to repeat, right? But the same skill can be applied, can be there in multiple employees. So the combination is going to this is composite primary key, so the combination is going to identify this employees. Okay, but the bottom line is that, okay, what is the bottom line? Simple attribute is mapped simply. Composite attribute is mapped by its components. And for a multi-valued attribute, we are going to make a new relation with the foreign key in it and the attributes of the uh, multi-valued attribute. Okay. Next is our weak entity. So we discussed weak entity in the detail when we were discussing when we were discussing ERD. So this is that particular example for you. So we have this employee entity, employee ID, employee name. We have discussed how it is going to transform. The important in this particular slide is this dependent, right? So dependent is our weak entity. It has dependent name, which is which is like composite, right? It consists of first name, middle initial, last name, and it has two more attributes: date of birth and gender. Okay. So what is going to happen over here? We will have two separate relations, right? One relation is for employee and another relation is for our dependent, right? So how many attributes are in our employee? Okay, so let's say that we are labeling our employee name as it is, right? So if we say that this is like the simple, it's just a single value, right? It's atomic, right? We have in employee, we have in employee relation, we have employee ID and employee name. What about dependent? Okay, so dependent will have one, two, three, four, five. Okay, so first name, middle, initial, last name, date of birth, gender. So these five attributes will be there. But since this particular employee and dependent has this one to many relationship, and basically what happens in one to many relationship, and you are going to look that shortly as well, that primary key from the one side goes to the many side, right? So dependent has this foreign key in it, right, by the name of employee ID. Okay. And one more thing, this dependent has no proper foreign key, primary key. Sorry. So this dependent name is not sufficient. This is not a uh, appropriate primary key. So what we are going to do, we are going to make the combination of employee ID and dependent name as our for primary key. So let me show you these two relations in the next slide. So here it is. Okay. As I was discussing that employee table will have these two attributes, employee ID and employee name. Dependent will have one, two, three, four, five, and one. The sixth one is employee ID. So this is shown over here, the six attributes. Okay, and the name was the primary key. So the name is divided into three parts, right? First name, middle initial, last name. But this was not sufficient. So what we did, we made this combination stronger by making employee ID part of the primary key as well. Okay, so this is mentioned over here. So you see, this employee ID is a foreign key which is connected to our employee table, and we have here composite primary key as well. Okay. So we have this composite primary key. It consists of four attributes: first name, middle initial, last name, employee ID. Okay. So the combination of these four is going to identify your dependent. So this is not a good approach, right? This is not the good. When I was discussing the primary key, and I mentioned that we prefer simple primary key uh, because primary keys are there for searching purposes, right? And if it consists of more than one attribute, it means, or in other words, composite attribute, so it means that our searching will take some time, right? So and here we our combination consists of four attributes, right? So it means that this is not uh, optimized. So what we can do, right, as a solution, we can introduce here surrogate primary. Okay. So the surrogate primary over here is that we are going to introduce a special attribute, right? And that attribute is actually is a serial number, right? So it is like it starts serially, right, and it increases. So here we have this dependent number. This dependent number was not there in the dependent. It is a surrogate primary, which we introduce so that we can get rid of this composite primary key, right? This is not good. It is not optimized. It will slow your searching. So what we did over here, we introduced this surrogate primary key. Okay, this dependent ID is our surrogate primary, and now this is going to identify our dependents. Okay, class. Next, we are going to discuss relationships. Okay, so first we are going to discuss binary relationship. Okay, so there are three possibilities inside our binary relation. The first is one to many, second is many to many, third is one to one. Okay, so there are three different type of binary relationships, and accordingly they are transformed. So let me discuss one to many. So in one to many, we have this primary key on the one side, right? I show you in the previous slide over here, right? This is one to many relationship. Okay, this was one to many, and what it was saying over there, it was saying that the primary key on the one side will become the foreign key on the many side. This is exactly what that was discussing. Let me show you. So primary key on the one side becomes a foreign key on the many side. Okay. So this is the case for one to many. For the case of one to one, let me discuss this before many to many. So for one to one, what happens? Primary key on the mandatory side becomes a foreign key, right? So primary key on the mandatory side becomes the foreign key on the optional side. And let me discuss the last scenario, many to many. Okay, so remember the example of the many-to-many relationship between two entities. So that means that we have this associative entity existing over there. So it means that we are going to have a new relation. This is what is exactly mentioned over here. For many-to-many binary relationships, you are going to create a new relation, right? With primary keys from the participating entities, right, which is going to become its primary key. Let me show you the example of all these three. Okay, so here you are looking at one-to-many relationship between customer and order entities, right? So customer has three attributes. We have discussed customer in detail, and the order has two attributes: order ID, order date. What are simple attributes, right? Order ID, order date. So how many relations? There are two relations, right? First is customer, second is order. How many attributes in customer? Three: customer ID, customer name, and if customer address is simple, it will have one. Otherwise, it will have for that many attributes as the number of components. And what about orders? So order will have order ID and order date, but right, we are not transforming this one to many relationship. It means that order has three attributes actually: order ID, order date, and the foreign key customer ID, right? The primary key on the one side becomes foreign key on the many side. See, this is what I was discussing. That customer ID becomes a foreign key over here, and it has this referential integrity connected with customer's primary key customer ID. Okay. And the next is our many-to-many relationship. So here we are looking at raw materials and vendors, right? So raw materials entity has three attributes: material ID, unit of measure, standard cost. Vendor has again three attributes: vendor ID, vendor address, vendor name. There is this relationship supplies. It has one attribute of unit wise. Okay, so raw material is supplied by at least one or many vendors, right, on a specific or on a given unit price. But it is not necessary for a vendor to supply any raw material. Okay, so you may have a list of vendors in which there exist some potential vendors who may give you raw materials in the future, but you have stored their data in the vendors table. Okay, so that means that those vendors are there and they have not yet supplied any raw materials, and there are other vendors who have repeatedly supplied you raw materials. Okay, this was the explanation of this ERD. So let's come to the relation schema. So how many tables will be there? Right? So there will be two main tables. First is your raw materials with these three attributes. Second is your vendor table with these three attributes. And then there is this third relation, right? For the by the name of this supplier, right? And supplier will have also three attributes: the foreign key material ID, the foreign key vendor ID, and the unit price, right? And this supplies have its own primary key attribute, which is your supplier ID. So let's discuss. Okay. Here, by the way, this supplies. Here, this supplies is represented as code, and at the moment it has just two primary keys, right? Which uh, which constituted your composite primary key, and then these are foreign keys as well. So your raw materials, as I was discussing, it will have three attributes. So over here you are looking at those three attributes. Similarly, for the vendor, I was mentioning three attributes, so you are looking at three attributes over here, right? For this supplies relationship, we are going to have a separate relation by the name of code, and it will have two foreign keys: material ID and vendor ID. Okay, and one its own attribute: unit price. Okay, so this is how we are going to make our a relation schema for many to many relationship. Next, I'm going to discuss one to one. Okay, so nurse, we are having this nurse entity with attribute nurse ID, name, and date of birth, and another is our care center with name care center, name as primary key, and the location attribute. Okay, so this in charge relationship will have, you are looking at an attribute which is part of in charge relationship. So what is happening in this mandatory one, optional one? Okay, so a nurse may or may not be in charge of a care center, but if nurse is in charge, only one nurse will be the in charge. So let's say we have list of nurses. For example, we have 10 nurses, right? So only one of those 10 nurses will be the in charge of our care center, and then there is data assigned. Then when she became the in charge, right, of the care center. But if we go from care center to nurse, care center has exactly one nurse as an in charge. Okay, so this is the explanation of this ERD. Now, how many relations will be there? So there will be two relations, nurse and care center. Second question is that how many attributes for the nurse? There will be three attributes: nurse ID, name, and date of birth. What about care center? Care center will have, of course, center name and location, but okay, so there are two things, right? We are going to make this nurse ID as a foreign key over here, because what happens, this mandatory one side's primary key becomes foreign key at the optional one side. Okay, so that's why this care center has actually three attributes: nurse ID, center name, and location. What about this date assign? So this date assigned will be the part of this care center, right? Because in care center we are mentioning that this is a nurse ID. Okay, this is the name of the center, this is its location, and this is the time when she became nurse. Okay, so this date assigned is more relevant to the care center than the nurse, right? Because in the nurse table we will have, let's suppose, 10 nurses. So what about date assigned attribute in the nurse? So it will be like maybe it will appear, the value, its value may appear in front of only that nurse who's in charge, but not for the rest. So it means that there are like null values, and it's, this information is also incomplete, right? Its better location is center, care center. Okay, so this is exactly what is shown. You can see that nurse and care center relations. So both relations are shown over here. And nurse has three attributes: nurse ID, nurse name, date of birth. Okay, three attributes. And care center has, of course, care center name and location. But care center has nurse ID as well, along with data signed. Okay, so and then there's referential integrity coming from nurse in charge to nurse ID. Okay, class. So next I'm going to discuss associative entities, how we are going to transform our associative entities. So associative entities can have two scenarios. The first one is that we have such associative entity um, where there is no for a primary key, and then there is another scenario when we have primary key. So let me show you both of these scenarios one by one. So look at here. This is a scenario where we know our um, primary key of the associative entity. Okay, so we have customer entity with customer ID name. We have vendor entity by the name of vendor ID, and we have vendor ID has primary key by the name of vendor ID and address. Okay, and this shipment is our associative entity, and its primary key shipment number. And other attributes are amount and date. So how we are going to map this ERD into our relationship? So we are going to make three entities. Three relations: customer, shipment, vendor. Customer will have these two attributes. Vendor will have also these two attributes. Shipment has this shipment number, amount, and date, but it has two foreign keys: customer ID and vendor ID. So actually there are five attributes for the shipment. Okay. So we have, let me show you, customer ID with two attributes, one, two, maybe there are attributes as well. Vendor ID with two attributes, right? So at the moment two attributes are shown, and there might be some other attributes. Shipment, look at shipment number, right? So it's the primary key, then amount, and then we have two foreign keys by the name of customer ID and vendor. And we have shown its referential integrity, right? Next is our unary relationships. Okay, so basically unary relationships we are going to discuss two type of relationship: one to many and many to many. For one to many, we are going to form recursive foreign key, that the primary key will become the foreign key, right? In the case of unary one to many. And if there exists many to many unary, then we are going to create another relation for the many to many, right? Okay, so let me show you the example. So this is the scenario where we have this employee entity in a unary relationship with itself, right? So employee manages optional many employees, but employees managed by exactly one manager. Okay, we have this employee ID, name, birth date. So what we are going to do, we are going to create this employee relation, right? It has these three attributes, and look at this manager ID. This manager ID is for this one to many relation. Okay, so this for for this particular relationship, we have this manager ID. Okay, so manager ID is is also the employee as well, right? So manager is the data of manager is retrieved by this employee ID, right? This is retrieved by this employee ID. Okay, so it means that the referential integrity exists from manager ID, which is the foreign key, to the primary key, which is employee ID. But note this employee ID, this is the primary key in the same table, so it means that this manager ID is a recursive foreign. Next is our many-to-many relationship in our unary case. So this is our item entity with three attributes: item number, name, and unit cost, and it has many-to-many relationship with itself, and its relationship name is contains, and it has attribute quantity. So there are two attributes. The first is so there are two relations. The first is your item relation with these three attributes, and the second is your component relation over here, right? Of course, it will have this quantity. Okay, so now what is going to happen? Since this particular component has many to many relationship with a single entity, it means that it will have two foreign keys coming from the same entity. Okay, so here you are looking at item number, component number. Both of these are shown and connected with this item number. Okay, so these two are a composite uh, key as well. But what kind of a key it is? It is actually, as mentioned, recursive, right? It is recursive in nature. Okay, so this is simple recursive key, while here in second case it is composite recursive. Okay, because both of these are connected with the item number item number primary key over here. Okay, next is our ternary relationship. So let me show you ternary relationship. This is a scenario where we have these three entities: patient, physician, treatment. Patient has two attributes: patient ID, patient name. Physician has again two attributes: physician ID, physician name. Treatment has again two attributes: treatment code, description. And then we have this associative entity in the middle by the name of patient treatment. It has three attributes: results, date, and time. Now, how many relations will be there? So there will be four relations. Okay, four relations. First for patient, then physician, then for treatment, and finally for patient treatment. So there are four relations. So how many attributes in each relations, right? So let me discuss. So patient relation will have patient ID and patient name. Physician will have physician ID, physician name. Treatment will have treatment code, description. But what about this patient treatment? Of course, it will have these three attributes, but this is like there in many-to-many relationship between patient, physician, and treatment. This patient treatment will have these three foreign keys. Okay, these three foreign keys, and now look what is happening. So, so these foreign keys are actually not. Its combination is not sufficient to identify patient treatment. So, what we incorporated, we incorporate date and time. It means that, say, a patient can come multiple times on the same date, but on the different times, and he can show himself to or herself to specific physicians for specific treatment. Okay, so it means that this patient can meet this physician and they can have the same treatment. on the same date, but on a different time. Okay, so the combination of all these four is going to uniquely identify. So this is not a good way. We are going to introduce surrogate key over here, right? Next is our the last one is our super type subtype relationships. Okay, so what is happening here? Let me show you. So this is our super type subtype relationships in which we have super type entity employee with five attributes and three subtypes: hourly employee with one attribute, salaried employee with two attributes, consultant with two attributes. Okay, so how many relations? Yes, class, how many relations? So there are four relations, right? One relation for one entity. So what are the attributes? So we have four relations: employee, hourly employee, salaried employee, and consultant. Employee relation will have all these five attributes. But hourly, it will have hourly rate, of course. Salaried employee will have these two: annual salary, stock option, and consultant will have contract number and billing rate. But remember, these three are subtypes of employee. It means that this employee ID will be part of each subtype, so that these relations are connected with employee, right? They are not separated. The link is there. Okay, so hourly employee will have two attributes: uh, primary key and foreign key, as well as of employee number and hourly rate, two attributes. Salaried employee will have three attributes: um, salaried employee number, which is the primary key, foreign key, both, right? Then annual salary and stock options, like three attributes. And consultant will also have three attributes: contract number, billing rate, along with employee number. Okay, let me show you. So this is what I was discussing. So one, two, three, four, five. So employee has these five attributes. Okay, hourly employee has one, salaried has two, consultant has two. Right? So hourly employee has hourly rate, salary employee has annual salary and stock options, and consultant has contract number, billing rate. But look at this thing. Right. So there is primary key, which was actually the foreign key. It's employee number. It exists in all these sub relations, and all of these are connected with their using referential integrity, connected with the primary key in our employee table. Okay, class. So this is it. This is these I have discussed. All of the examples and all of the aspects, how we are going to transform our conceptual schema into the relational schema. Okay, so this is an example which I am going to discuss, and then next is our task, and then we are going to conclude our lecture on the relational schema. Okay, class, so here you are looking at this patient super type, and it has two subtypes: outpatient, resident patient, and two more entities are there: physician and pet. The question is that how many relations are there, right? So there are five relations. So there are five entities. It means that there will be five relations, right? One is patient, outpatient, resident patient, physician, and pet. Patient will have patient ID, patient name, admit date. Okay. Outpatient will have check back date, resident patient will have date discharge, responsible physician has physician ID, pet has pet ID. So these are all the five relations, right, with respective attributes. But now let's solve for this one to many and one to one relationship. Remember, when we're discussing one to many, we recall that the mandatory side's primary key becomes foreign key on the many side. Similarly, for one to one, mandatory side primary key becomes foreign key on optional one side. It means that our patient relation will have four attributes: patient ID, patient name, admit date, and physician ID. The responsible physician will have physician ID, just right, and outpatient will have uh, patient ID and check back date. Resident patient will again have patient ID, date discharge. But there will be one more attribute of the resident patient, that is a bed ID, which is coming from this one to one relationship. Bed has one attribute, Okay, so these are the five relations which I discussed and their respective attributes and the referential integrity constraints and primary key and foreign key. Everything is on here. The foreign keys are shown by bold italic, right? The primary keys are shown by bold underline. Okay, class. So this is the task for you. So this is again another enhanced CRD, and what you are going to do, you are going to make logical slash relational schema for this task. Then you are going to show me in the next class, which is on Thursday, and then we will discuss. Okay. So this I'm going to conclude this video recording. We have discussed relation, right? We have discussed how to convert our conceptual schema into our logical slash relational schema in detail. We have discussed each and every component of the conceptual schema and its conversion into relational schema. And I hope you liked and enjoyed this lecture, and I'm looking forward to your relational schemas. Okay, class, thank you. See you in the next recording.